is the war with cancer, or is that war within ourselves? Right? It's a question for us to consider, because we all start with a biological terrain that looks healthy. When we're born, the microbiome and all these things are fine. But as we increase our years in this planet, we go through abuse and neglect, this terrain, biological terrain, starts looking not nice. Toxic, environmental toxins, heavy metals, thoughts, and so forth. So, how is our strategy for cancer good enough? And so let's look at how and what we know about cancer today. And, in 2023, we know a lot about cancer. So if someone calls Hope for Cancer and says, have you treated a leiomyosarcoma? Or how many of this very rare ovarian cancers have you treated? It's not about treating the type of cancer. It's about working on the foundational characteristics of cancer. And there are 14 of them, 14 biological hallmarks of cancer. Of course, I can't go over every one of these today, but they're all in my book. Actually, only 10 of them are in my book because the last 4 came out after my book was published. And so if you want to take a picture of the 14 biological hallmarks, this is the slide to take a picture of. And then we're going to go into them in groups of 3 or 4. So the first one, the group, is that cancer cells manipulate cell growth signals and their ability to spread. So cancer cells are very smart. They're going to bypass suppressive cell growth signals. That means, for example, there's some signals in our body that stop cancer cells from growing, but cancer cells are able to suppress these signals. And so it's very important also to see that cancer cells are able to hijack senescent cells, altering their signaling patterns. Because every cell in our body is communicating with every other cell. We're truly a communication pathway. And so that's why the thoughts in the mind is so important. Because a negative thought is going to filter to every single cell in your body. And then cancer is going to vibrate low, which it does. Negative thoughts vibrate low. Viruses vibrate low. And so cancer cells is going to have an easier time to grow, progress, and metastasize. Here's an example of a study that was done at the University of Iowa, and they saw how healthy cells are hijacked by cancer cells. So meaning, if I'm a healthy cell, I emit like a lasso from my cell membrane and rope in neighboring healthy cells. If I'm a cancer cell, I'm going to rope in neighboring healthy cells. And you'll see this now, where the arrow is pointing, that's where the lasso comes out. They call it the lasso effect. And you saw there, I'll play it once more, how the cancer cell on the left is emitting like a lasso to bring in healthy cells, to expand its growth, and to become harder for the immune system to attack that cell. So here you see the second category of the biological hallmarks is cancer cells avoid detection and destructions. Cancer cells are masters at hiding or shielding themselves from being seen by the immune system. So it's not only good to have an optimal white blood cells, T lymphocytes, B lymphocytes, and all these immune cells, but it's important for these immune cells to be able to see the cancer cells. And so cancer cells also resist cell death. They're not going to die. Remember, every cell in our body has a limited lifespan, every normal cell. Cancer cells have no birth control, right? They're going to reproduce and reproduce. And so this is another hallmark or characteristics of all cancer cells, whether it's pancreatic cancer, colon, breast, lung, every cancer cells have these characteristics. And here you're going to see a little video of how these generals of the immune system, these tough immune cells called cytotoxic T cells that are part of the adaptive immune system. Remember, there's 2 parts of the immune system. The quick-acting immune system called the innate, that's when you sneeze, you cough, and you get a bug, and the quick-acting immune system kicks in right away to suppress that pathogen. On the other side is the adaptive immune system. This is more the memory immune system, and cytotoxic T cells are part of the adaptive immune system. So you see in the green is that cytotoxic T cell, the blue are the cancer cell. So you see how the immune system, in this example, the cytotoxic T cells are attacking and engulfing the blue, which are the cancer cells. And this was done out of Cambridge University in the UK. So this is happening every second of every day, because according to some research, we're all producing about 100 to 150 cancer cells a day. So what are you doing today to not allow these cancer cells to proliferate? So we have to start today, not mañana, as they say in Mexico, right? Today, hoy. So the next category is the ability of cancer cells to modify the genes. You all know that cancer is seldom a genetic disease. Only 2.5 to 5% of all cancers are truly genetic in nature. Only 2.5 to 5% of cancers are genetic in nature. So if you go to your oncologist and you ask him or her, Doc, why did I develop this cancer? What's the first question they ask? Is there cancer in the family, right? And if you say yes, that's why you have cancer. But if you say no, then, they scratch their head. And some of my patients have told me that doctors have told them that they got cancer because bad luck, or they did something to deserve it. The worst of it is they say God gave it to them. Imagine that one. Patients have told me that their oncologist has said that to them. So it's not about the genes, it's about epigenetics and what turns that gene on. As we move forward, we see that a precancer cell, let's say it looks all blue, all the cells in that look blue. As the cells are mutating, now you have blue, some orange, and then further mutations, see how that tumor is changing, right? It's not the same as when it started. This is called clonal expansion. And this gives cancer cells an advantage to survive. And ultimately, you see, when there's further mutations, on the right, it looks totally dissimilar to how that cancer or that precancer process started. This is why when someone has chemotherapy, they'll say, well, the tumors in the liver decrease in size, but the one in the lung increase. So why is that if they're all the same? But they're not all the same, as you see here. And as you look further in the next slide, a primary lung cancer on the far left, as that cancer is growing and ready to metastasize, is changing, you see? And then when it metastasizes to the liver and to the brain, totally dissimilar to the original tumor. And so this is why in conventional oncology, they give you 2 or 3 different chemotherapies. Try to hit these divergent and heterogeneous types of cancer cells. Is this making sense? Okay, questions are at the end of the 2 hours, remember, okay? Yes. This is very important to know because we all think that all cancer cells are the same. And if you had a primary breast cancer, let's say, and now it's in the lymph nodes, it's the same. It's not exactly the same. And so the next category is that cancer cells change the body's physiology in the tumor microenvironment. What that means is, remember, we said that that terrain is changing as we age, as we go through life, and as we neglect healthy lifestyle and abuses in life. So these are advantages that cancer cells have to grow. I believe that cancer is an opportunistic disease. If given the opportunity, it will form. No one has ever seen a cancer cell metastasize in real life. How does a breast cancer cell go to the liver or the brain or the lung or the bone and survive? How could that happen? So I'm Colombian, born in Colombia, South America. grew up in New Jersey and work in Mexico. Figure that one out, right? But so then I go to Germany. I have a good friend of mine here in Germany, and I don't speak the language. I don't like sausage. I don't drink beer. And so how am I, a Colombian, Mexican, American, how am I going to survive in Germany? It's a different world. It's a different terrain. So what do? I call my buddies in Germany. And so they give me the environment where I can survive. Well, cancer cells do the same. If they started in the breast, let's say, they form their microenvironment. That means heavy metals, that means hypoxia, that means inflammation, that means mold and fungi and parasites and all this. They build their microenvironment. It's called a TME, tumor microenvironment. And then they take those with them. If this is a fungus, let's say, and something else is a bacteria and parasite, cancer cells take that with them. They go to Germany, and now they form a niche there. They go to the lung, the brain, the liver, the bone, and now that breast cancer cell can survive in a distant organ, just as Tony could survive in Germany, right? So is that clear? Because this is very important. This is why it's not only about attacking the cancer cell, it's about the tumor microenvironment. And from those of you that are here that are going through that challenge of progression of disease in lieu of a lot of things that you are doing or have done, the question is always what's missing, right? And so I started out with reading that brilliant extract from Fred Rohn's book. So let's consider all those things. What's missing?